Hello guys, I created an AFSM LFA using the cadence tool. My name is Sangjin Kim and I'm currently taking a digital circuit design course at Dongguk University. The system input includes clock reset, steering left and right line to make the car parallel with the lane, and finally the hold button, which maintains the current direction when you release the steering wheel. For the output, the system uses a 7-segment display to show the current position of the vehicle and the LEDs to indicate whether the LFA sensor is on or off. There are two cases where the LFA sensor turns on. These cases are determined by analyzing human intention and deciding whether to activate the LFA sensor. Let's first look at the car moving to the right. The steering wheel is turned right, and the car continues in that direction. Even after pressing right and then pressing hold, the car will keep moving to the right. Now let's look at the situation where the elevator turns on. The car first moved to the right, then we press a line and release the steering wheel. This is the hold state. In that situation, the elevator activates and the car moves back to the center of the lane. For simulation, I entered the exact digital code values for the inputs and outputs. This is the result of simulating the car moving to the right. The simulation worked really well, and it also shows the situation where the car stabilizes into the center. It even accounts for the random scenarios as well. Now let's look at the layout I designed. On the left side, you can see the input pads connected, and on the right side, the 7-segment display A to the G and LED. For the unused pad at the top, I connected additional VDD for power stability, and the ground is connected at the bottom as well. On the left, the inputs are connected to ESD protection pad. On the right, the output drivers also have ESD protection pad, which improves circuit stability and ensures reliable output. In the overall layout, there's a SM, NSL, and OL like this, represent state memory, next state logic, and output logic. Finally, let's check if the circuit was built correctly. For this assignment, density rules and the pad considerations were not required, so the results comes out really well. And for the LBS check, gave a positive result. It worked perfectly.